Math with Dave.
Well, hey everybody, here's Dave to talk about multiplying and dividing radical expressions, which is an extension to the first lesson on the basic operations with radicals. Again, I would say that if you don't have a strong grasp on your ability to reduce radicals or to write them in mixed radical form, I would go back and take a look at the first video before you move forward, because we're going to be applying those skills right now. Let's say we have a question like this where we have 2 root 7 times 4 root 75. There's really two schools of thought when it comes to how to deal with it. The first school of thought is let's just multiply everything together and see how it goes. And when we do so, we're looking at the blue box here. We can see that the trick to multiplying radicals is you multiply the numbers with the numbers and the radicals with the radicals to give you what's on the right hand side. From there we can see that 2 times 4 is 8 and 7 times 75 is 525. This is where this particular method may bother some people, because if you don't reduce the radicals initially, you're going to get a big number like this. Now, it's not impossible if you know how to do factors quickly, and so when I look at this particular number here, what I see is, well, I got it by getting 7 times 75, and I also know that 75 is 25 times 3. Well, there's your perfect square that we're looking for, which allows us to reduce this even further, because now we know that it's 25 times 21. So now we can go 8 times the square root of 25 times 21, which gives us, well, the square root of 25 is 5. 5 times the 8 in front is 40. And what are we left underneath but the 21? 21 may really trip some people up because they look at that number and they figure that it should reduce further. But again, from the previous lessons, we talked about the idea that you have to look for those perfect squares. And underneath the radical right now, I don't see a single perfect square, so we're good to go that way. Now, instead of going right to multiplication and then figuring out factors of a large number, what we can do first is we can actually break up our radical and simplify it, and then we can deal with it after the fact. So if we take a look here, we have 4 root 75. Well, we can rewrite it as 4 times the square root of 25 times 3. That allows us to now break this up into, well, the square root of 25 is 5, and what we're left with is the square root of 3. And now we have 2 root 7 times 20 times the square root of 3. That allows us now to multiply the outside numbers. 2 times 20 is 40, and the square root of 7 times the square root of 3 is the square root of 21. And so again, we're left with exactly what we got in the first method, but I would suggest that reducing your radicals first is a great way to go before you move forward, just simply because you will end up with numbers that you'll be able to reduce simply. So let's take a look at a couple of pretty basic ideas here. Again, recognize the fact that these are the restrictions on this particular radical because it's the square root of 2x, but at the same time, we're going to follow our methods, and we're just going to multiply the outside numbers, which is negative 12, and we're going to multiply the inside numbers, which is 2x times 6, which is just 12x. You think you might be done there, and unfortunately you're not, because that 12 there can now be reduced. So again, this is where it's important to, once you multiply, be sure to take a look to make sure that you can't reduce any further, because we can. Because I know that 12 is 4 times 3, and that 4 now, the square root of 4 is 2. We have that negative 12 out front. I'll write this out explicitly so that you can see it. You have 2, and what we're left with is 3x, and negative 12 times 2 is negative 24 times the square root of 3x. So there's that one additional step, and I promise you there's no math teacher alive that's going to be okay with you just multiplying it together and leaving it unreduced. So please make sure you simplify after the fact. With the next question, we got to watch out, because again, this requires us to do some expansion. And you've all learned at some point how to expand a number in. Here in Canada, it's in grade 8, where we take a look at multiplying these things together. And what are we left with? Well, we're left with 7 times 5, and then that's root 3 times root 5. Subtract 7 times 6, and then root 3 times root 3. Now, we got to watch out for that negative sign, but outside of that, this is pretty straightforward. We see a 7 times 5 is a 35. Square root of 3 times 5 is the square root of 15. And we're going to subtract from that. 7 times 6 is 42. And the square root of 3 times the square root of 3 is 3. And that's one of those properties that we're going to want to make sure we remember. The square root of anything times the square root of anything is just that number underneath it. So the square root of 9 times the square root of 9 is 9 all day long. We can go one step further and we can say, okay, well, 42 times 3 is 126. And from there, I'm pretty content. So I think at that point, we would say that we're done. You could probably factor out a 7 if you wish. I don't care. So it's really that straightforward. So there we go. That's our next one. So again, notice that in that particular case, we were left with two terms. Remember that to simplify as far as possible doesn't necessarily mean that it has to eliminate all terms and just combine them into one. So be prepared for that. So if we take a look at example problems, this is where I would pause and start playing with them yourself. At the same time, I'm just going to keep pushing through. So the first thing I'm going to do is I'm going to multiply the numbers by the numbers and the radicals by the radicals. There is no other number, so this is just 5. And then the square root of 3 times 6, which gives you 5 times 18. We're not quite done yet because 18 is actually 9 times 2. And if we break this up just so you can see it, the square root of 9 is 3. 3 times 5 is 15, and that square root of 2 stays the same. For those of you that want to use calculators to check your answer, that's not a big deal. Just make sure that every single decimal place matches, because if even one doesn't make sense, then you've gone wrong in some way. Typically because you haven't multiplied numbers together right. For example, 3 times 6 is 9 or something weird like that. If we look at the other one, we're going to expand through again. The thing I want to point out there is there's that index of a cubic. So we're actually taking the cube root of 11, the cube root of 2, and the cube root of 3. So it's the same process as far as multiplying them together, but if we wanted to pull something out, we'd have to take the cube root. If we had to put something back in and do an entire radical, we would have to cube it. So we have this here, and now let's go. So negative 2 times 4 is negative 8. The cube root of 11 times the cube root of 2 is the cube root of 22. And then we're going to go negative 2 times negative 3 is a positive 6. And then the cube root of 11 times the cube root of 3 is the cube root of 33. I'm looking. I am not seeing any perfect cubes in either one, which means that that's our final answer. You'll notice when I write that index in the radicand or in the radical, I do a good job to make sure that it's a whole lot smaller than that coefficient in front, just so I don't confuse myself down the road. Let's do a couple more. This is one that people typically mess up because it requires us to remember how to FOIL. Remember, FOIL means first, outer, inner, last, and that's just a way to remember multiplying numbers. I've been doing math likely longer than you've been alive, and I promise you that I still draw these arrows today just so that I make sure I don't screw it up later on. Okay, so if we expand these out now, 4 times 1 is 4, square root of 2 times square root of 7 is square root of 2 times 7. Subtract 4 times 5 is 20. The square root of 14 times the square root of 2 is the square root of 28. And now we do the inside. The square root of 7 times 3 is just 3 root 7. And 3 times negative 5 root 14 is negative 15 root 14. So the first step is you expand everything out so you can see it. Now we can start reducing. So if I look at the first one here, I just have 4 times the square root of 14. Well, there's nothing I can do there. However, if I look at the second one, 28 has a perfect square in it, and that's 4. So I can rewrite this as square root of 4 times 7, and 7 is a prime number, so we're good to go there. And this one also cannot be reduced. People might want to sit there and try to split it up into root 2 times root 7 or something like that, but that isn't really simplifying anything for you. Now we can write this out again, square root of 14. Subtract, well, square root of 4 is 2. 2 times 20 is 40. Root 7 plus 3, root 7, subtract 15, root 14. Well, there's all our terms, and you'll notice we have a couple of the similar radicals. We have 4 root 14 minus 15 root 14. Well, that's just going to give you minus 11 root 14. And then we have negative 40 root 7 plus 3 root 7. That's subtract a 37 root 7. So again, they're not the prettiest numbers, but at the same time, those are the two terms we're dealing with. Okay, and with D now we just expand through like we did previously. This time we have a variable, but that's not a big deal. All we do is we multiply the numbers together as usual, which is negative 2 times 4. Underneath the radical, we have 11 times 2 is 22. C times c cubed is c to the power of 4. And we'll subtract from that. Negative 2 times negative 3 is a positive 6. And then root 11c times root 3 is root 33c. Now we can reduce a little bit because you see there's that perfect square underneath, which means we can actually take this now and we can say, okay, well that's negative 8 times the square root of c to the power 4 square root of 22 plus 6 root 33c, and we get negative 8c squared root 22 plus 6 root 33c. So just remember that when you deal with variables underneath the radical, you have to have an even number, or you have to have whatever number in front of the radical, the index, needs to divide into this power evenly. If not, you're going to break up that variable to do so. When we're dividing radicals, it's really just the same thing. We're going to divide the numbers. So 4 divided by 2 is 2. And the cube root of 6 divided by the cube root of 3 is really equivalent to the cube root of 6 over 3. Well, that's just 2. So this is equal to 2 times the cube root of 2. So again, exponent rules would be really helpful in this case. So if you can't remember your exponent rules, you're going to want to go back and remember that this is really just 6 to the 1/3 over 3 to the 1/3, and that by definition is going to be 6 over 3 to the 1/3. So I really impress upon you the importance of knowing your exponent rules to do so. But otherwise, it's the same process as multiplication. Just make sure the radicals have the same index and we're good to go. So let's take a look at a question like this. We have 5 over 2 root 3, but now we're going to do something called rationalizing the denominator. And when we rationalize the denominator, all that means is no radicals on the bottom, please. So the easiest case is when you have a term on the bottom multiplied and one of them is a radical. When that's the case, we're going to multiply the top and bottom by that radical. So in this case, we're going to multiply the top and bottom by the square root of 3. There's absolutely no reason to multiply top and bottom by 2 root 3 because that 2 is going to cancel anyway. Remember, the whole purpose of us multiplying top and bottom by root 3 is we're just trying to get rid of that radical. So when we do that, now what do we get? Well, on the top, we get 5 times the square root of 3. And on the bottom, we have 2 times the square root of 3 times the square root of 3. Well, remember, the square root of 3 times the square root of 3, well, that's just equal to 3. So what we end up with is 5 root 3 over 2 times 3, which is 5 root 3 over 6. So that's a whole lot of steps to show to get you there, but the whole point is when we have simply a radical on the bottom, we just multiply by it. But what if we have a question like this? We have 5 root 3 divided by 4 minus root 6. We can't simply multiply top and bottom by the radical because what will happen is that term out front will have to be multiplied by the radical too, and you'll still be left with a radical. So what we do is we multiply the top and bottom by what's called the conjugate. And the conjugate can simply be recognized as the exact same thing as the denominator, except for we've changed the sign. So if that was a 4 plus root 6 in the original question, we'd have 4 minus root 6. And the reason we do this is because if we expand this out, what's going to happen is we actually create a difference of squares scenario that you saw with quadratics, which means we're just going to end up with the first term squared minus the second term squared, and we'll be done, which is fantastic. It's going to make the math easy, especially when you see the pattern. So if we start writing this out now, what do we have? Well, we have our top term there, which we can multiply. So 5 root 3 times 4 is 20 root 3. And 5 root 3 times root 6 is a plus 5 root 18. On the bottom, though, something cool happens. 4 times 4 is 16. And we're going to add a 4 root 6. And we're going to subtract a 4 root 6. And then we're going to subtract root 6 times root 6 is just 6. So you know you've picked the right conjugate if that happens to the middle terms, if those two things cancel out. Otherwise, we have a problem. This allows us to clean this up now. We'll reduce this one radical right there. That square root of 18 is really the square root of 9 times 2, which is 3 root 2, which means we can rewrite this as 20 root 3 plus our 5 times 3, which is 15 root 2, and that's going to be divided by 16 minus 6, which is 10. You're almost done, but you might notice that at the top there's one thing that can be factored that we can reduce with the 10, and that's this idea of a 5. So I'm going to show you quickly that the way I want you to think about it is like this. With the top, if I factor out a 5 on all the terms up top, I end up with 4 root 3 plus 3 root 2. And I'm going to write the 10 over here just to be explicit about what we're doing, which is we're canceling the 10 or the 5 over 10 to be a 1 over 2. And the reason why I write it like this is simple, is because some people think that you can just cancel one of the terms and that's fine. For example, I could take the 20 divided by 10 as 2 and then move along. But that's just not so. You have to have a common factor between both of those terms, and it has to be something that this will divide into easily. So our actual answer then is going to be 4 root 3 minus 3 root 2 divided by 2. And so that would be the most simplified case. I'm not super hardcore about this, but at the same time, if we're being reasonable, this is as reduced as it gets. So if you're ever uncertain if you've done it right, just check your decimals and see what this looks like in the calculator. You should get identical results when you do so. So let's take a look at a couple examples then. What if we have a cube root? Well, cube root means that if we just multiply the top and bottom by the cube root of 3x, the problem is the cube root of 3x times the cube root of 3x won't be 3x. So we actually have to multiply top and bottom by the cube root twice. So again, we only had to multiply by the square root once because it's a square root, and square root times square root will be whatever's underneath. With a cube root, that means you have to multiply it by it twice. So when you do so, what do we get? Well, we end up with, this is just going to be equal to, on the top, the cube root of 5 times 3x is 15x, times 3x is 45x squared. And on the bottom, the cube root of 3x times the cube root of 3x times the cube root of 3x is just 3x. So the only trick to cube roots is just remember you have to multiply top and bottom by the radical twice. It's not just a square root. With b, we're back to a square root and we're back to a conjugate case, but this time this is an addition, so we're going to go times the square root of 5 minus 7. Remember, we're trying to get this difference of squares scenario, and that's going to get us there. So if we multiply like that, what do we get? Well, on the top, we get 11 root 5 minus 77. On the bottom, we get the square root of 5 times the square root of 5, which is 5, minus 7 root 5 plus 7 root 5 minus 49. Those will cancel out, and all you're left with is 11 root 5 minus 77 divided by 5 minus 49 is a minus 44. Well, it looks like I have something else I can factor out, and that would be if I factor out that 11, because if I factor out an 11, what am I left with? I'm left with the square root of 5 minus 7, and that's over negative 44, and that's going to cancel to give me a 4, which means my fully reduced answer is root 5 minus 7 over negative 4. That negative sure doesn't look good down there, so let's remember that that negative could be beside the fraction. It could be up top if we wish. That one doesn't matter. I'm just leaving it down there so that you notice where that ended up. Remember, it started here. Okay, so we finally made it to where you get to try these out. Again, I would pause just to make sure that you're doing it right. Before you see the way I do it, I would go through both and then see if you're right. Otherwise, here we go. So for the first one, I see that I actually have a trick I can use instead of multiplying top and bottom by root 3, and that's if I actually do this division right there. And if I do that, I get 2 times the square root of 51 over 3, which is equal to 2 times the square root of 17. And hey, guess what? That's done. So we're all good there. Yes, you could have gone top or bottom by root 3 over root 3, and you would have eventually reduced down to this. But again, if you can see a way to simplify at the beginning, then you should start with that. With b, I see I have root 4x plus 1, so I'm going to multiply the top and bottom. I'll get this out of the way. I'll multiply the top and bottom by the square root of 4x minus 1, again, so that I can create a difference of squares scenario. And now I can multiply the top. Remember that you have to multiply all the terms. So 6 times the square root of 4x is 6 root 4x minus 6, and that's divided by square root of 4x times square root of 4x is 4x plus root 4x minus root 4x minus 1. Remember, the whole point is that we reduce it down to two terms without a radical on the bottom. Now, some folks might want this to stay as 6 times root 4x minus 1 over 4x minus 1. It's up to you. Bye.